formula, here we come. Okay, so when you first look at this, you may be tempted to first distribute the minuses, and then you have two trinomials, and you have to distribute 3 times, and that's perfectly valid, and it will work. But there is a little bit more of an elegant solution. I'm going to take advantage of the fact that addition is associative, and I'm going to regroup some things. So I regrouped the x minus 1's together, and now I have basically a binomial. Think of the x minus 1 in parentheses, think of it as just one entity. Okay, so if I do first, I would have x minus 1 squared. If I did outers, I would have negative 3i x minus 1. And if I did the inners, I would have plus 3i x minus 1. So they're going to add to 0. And last, I have minus 9i squared. Well, 9i squared, I mean, we can't leave I squareds in there. So what we really have is we have x minus 1 squared plus 9. And x minus 1 squared is x squared minus 2x plus 1, and the plus 9 is left over, so I have x squared minus 2x plus 10. Okay, what I was saying was I was going to take this and I was going to divide it into our original. So our original is x to the 4th minus 3x to the 3rd plus 6x squared plus 2x minus 60. And I am dividing x squared minus 2x plus 10 into that. Okay, what times x squared would give us x to the 4th? X squared times x squared would give us x to the 4th. X squared times x squared is x to the 4th. X squared times minus 2x would be minus 2x cubed. X squared times 10 would be plus 10 x squared. Change the signs and bring down. So I have a minus x cubed and a minus 4x squared. Bring down. What times x squared would give me negative x cubed? A negative x times x squared would give me a negative x cubed, and a positive 2x squared, and a negative 10x. Change the signs and bring down. So we have a negative 6x squared plus 12x. Bring down. What times x squared would give me a negative 6x squared? It would be a negative 6. So I have a negative 6x squared. I have a positive 12x and a minus 60. Change the signs and we have no remainder, which we kind of expected, right? Because we already knew that 1 plus 3i and 1 minus 3i were 0. So it would make sense that when we multiplied them together and divided them into the bigger function, we would come out as a 0 remainder. So what I have left is x squared minus x minus 6. And if it factors, it would be factors of 6 that have a difference of 1. And looks like x minus 3x plus 2 will fit the bill. So my full list of zeros, I have positive 3 and negative 2 to add to that. 3, negative 2. To factor completely, I have, let's write them all out. 1 plus or minus 3i. So I have x minus 1 plus 3i, x minus 1 minus 3i, x plus 3, x minus 2. 1, 2, 3, 4. 4 zeros. Okay. Start it all over, just so you can see the other way. Some of you may like this better. So what I did was, since I know that 1 plus 3i is a 0, then that means it must synthetically divide. And isn't that crazy? Well, yes. Yes, as a matter of fact, it is crazy. But that's just the perfect reason to do it. So started with the coefficients here for my synthetic division. And we start by bringing down. And anything times 1 is just that thing. So we have a 1 plus 3i. And we need to add down. Negative 3 plus 1 is going to leave us with a negative 2 plus 3i, because you do like terms, right? Multiplying. Okay, so these are binomials, so we're going to have to do first, outer, inner, last. And I like to do this off to the side. So I have first, and if I'm going to write this down once. Here's what I'm doing. It's 1 plus 3i times negative 2 plus 3i. So let's see. First, 1 times negative 2 is negative 2. The outers will be 3i, right? The inners will be negative 6i. That's going to leave me with a negative 3i. And then the last is going to be 9i squared, which is actually negative 9. So what I have is negative 11 minus 3i. And I add down. So I have negative 5 minus 3i. And here we go again. Scratch that out. So we have first, 1 times negative 5 is negative 5. The outer is going to be negative 3i. The inner is going to be negative 15i. That ends up being negative 18i. And last we have 3 times negative 3, which is negative 9i squared, which is positive 9. And so we have 4 minus 18i. Add down. 4 and 2 is 6. Okay. So we go again. The first, 1 times 6 is 6. The outers, 1 times 18 is negative 18i. The inners, 6 times 3 is positive 18i. That means there's no i's. And what's left is 3 times negative 18. So that's going to be a negative 30 and 20, 54 I squared, which is going to make that positive. 6 times 54 is 60. Negative 60 plus 60 is 0. So doesn't that just blow your mind that just worked? So if 1 plus 3i is a 0, 1 minus 3i is a 0 because they come in conjugate pairs. So bring down the 1. 1 minus 3i times 1 is 1 minus 3i. Add down negative 2 and 1, so negative 1 and 3 i's are gone. So this is going to be a negative 1 plus 3i. And if I add down 5, then it's going to be negative 6 minus 3i plus 3i is 0. So I have negative 6 times 1 minus 3i. This is going to be a negative 6 plus 18i. 6 minus 6 is 0. Negative 18 plus 18 is 0. It works. So what I'm left with is x squared minus x minus 6. And we're hoping that that factors. And it does. Which is what we ended up doing with right here. So, pick your poison. There's 2 ways to look at that. Hope it's been exciting for you. I'm sure that it has. Let's pick a few. These are on page 267. Let's pick, how about 26, 24, 25. 19, 24, 25, and then how about 49? How about 49 to 51? Beautiful, eh?